Here boron is the central atom. So, the atomic number is 5 for boron and the ground state electronic configuration is 1s2, 2s2, 2p1. In the excited electronic state, one of the electrons from the 2s orbital will go to the 2p orbitals. So, therefore, in the excited electronic state, the electronic configuration will be 2px1, 2py1, 2pz0. This will form the sp2 hybrid. Therefore, the hybridization is sp2. So, we have 3 bonds in BF3 and each bond represents 2 electrons. Therefore, the correct answer is sp2 and 6. You might think that why we are not counting the 1s2 electrons here. The reason we are not counting the 1s2 electrons is because they are not involved in bonding. So, we do not need to count the number of electrons that are not involved in bonding. We should only count the number of electrons that are involved in bonding. The additional 3 electrons come from the each fluorine atom. Fluorine, you know the electronic configuration is 1s2, 2s2, 2px2, 2py2, 2pz1. We have 3 fluorine atoms. So, those electrons are contributing for the bonding with the each sp2 hybrid. The 2pz orbital will form a bond. So, like you have, let us say if you have a boron atom like this, then the 2pz orbital will form the bond. So, here you will have the bond. Yeah. So, only 6 electrons you should count. You should ignore the 1s2 one. So, therefore, this answer is correct.